Okay, guys, here we go. So let's finish this off. So we have two different triangles. Now, again, if you're not sure what the heck, how did I come up with two different triangles, just stick around for office hours, okay? Sometimes I feel like, yeah, my videos are a little rushed, okay? So stick around for office hours and I'll go real slow, okay? Make sure that you get it. Or ask a question right now, okay? All right, so here we go. We have two triangles. So we have this case or this case. We have two cases. Now let me back up. That is when we're solving for a triangle where they only give us one angle, right? And when they're giving us one angle, you have two cases. Either it's going to be an obtuse angle, and that turned out to be pretty easy, okay? Or in the case when the one angle that they give us is acute, okay? The first thing we have to check is what is the height of that triangle based on the information, okay? And if that missing side, or if that extra side is not long enough, we don't have a triangle. But sometimes the missing side will be long enough, okay? And from here we break off into two more, okay? Not just these two. There's another case that I'm getting to. Just wait. But anyway, in this case, we have the height was 10, okay? And that extra side was 13, so we can draw a triangle this way, because if the shortest distance down to the base is a perpendicular line, okay, then it's going to be longer to draw it to the base this way, and that's 13. But as you guys can see, you can also draw it this way. So you get this triangle right here. That's what I drew right here, okay? Or you could have the case where it drops down this way, so we have another triangle, okay? So we have two triangles. So now what you have to do is solve both of these triangles, okay? So we know that the sine of 40 over 13, so here's my, what is this side, or angle C? So this is side C. This is side A, so this is angle A, and then this is angle B, and this is side B, okay? And now just set it up. Sine of 40 over 13 equals sine of A over 16, and solve it, and then solve for the other one. So you're going to do two different equations, and then over here you're going to have to do the sine of 40 over 13 equals the sine of A over 16, okay? Kind of a lot of work, right? You're going to have to do it twice, okay? So if you get a case like this, okay, it's just, God, it's a lot of work, okay? And I'm not going to do it for my notes because we've done a bunch of them, okay? Let's do one more case, all right? I'll do, let's see, let me get another piece of paper here. I'll do one more case where we'll do the exact same thing, okay? We'll do the exact same thing so we don't have to do so much work. I'm going to give you that A is 16, I'm going to give you that C is 40, but this time I'm going to give you that side C is like 17, okay? So watch this. All right, so here's the next case. This way we don't have to do quite as much work. We could get through this example kind of easy. So here we go. Side C, I'm just going to say it's 17 this time, okay? Side A is 16, and then angle C is 40, okay? All right, so again, I like to put my angle down in the bottom left corner, so here's 40, okay? And again, to the best of my ability, I'm going to draw a 40-degree angle. It's something just like that, okay? All right, so this is angle C. Across from angle C is side C, so that's where my 17 is going to go, okay? And then this guy right here is 16, so I'll make this guy 16. Now, again, because this angle is acute, we want to check the height, okay? All right, we want to know what that height is, okay? But we already know what the height is. It was 10.2. The height was 10.2. All right, so this guy right here is 10.2. So we're good. 17 is certainly longer than 10.2. Now, let me show you. Here's what's good about this case right here. The 17, that's the other side, right? Certainly, you know that if I draw a line from here to here, it's 10. That's the shortest distance from the top to the bottom. So if I draw it out this way, okay, certainly it's got to be longer than 10, and I think we have a triangle, okay, if this is 17. That's fine, okay? No problems there, okay? Now remember this case when I was able to draw it this way but also this way, okay? Can I draw it this way? Yes, 17. Can I draw it this way? No. Why not? Well, here's the deal. What's the distance from here all the way to here? That's 16, isn't it? If I was going to draw from here to here, what do you know about that line? It's less than 16, right? That line from here to here would be somewhere in between 16 and 10.2. So the only choice that I would have if I was going to draw it in this direction would be over here, which is outside of the triangle, and it doesn't even make a triangle, okay? So in the case where you have an acute angle, okay, but this side here is bigger than this side, you're only going to have this one triangle, okay? You're going to have this guy right here, okay? And that's it. And so let's go ahead and solve this one. So this is angle C, this is side C. Again, if you have any questions, just say something. This was side A, so that means this is angle A. And then this is angle B, and this is side B. And then we'll go ahead and solve this, and we'll be done. All right, here we go. So I know, I'm going to take the two things that I know. So what will I be solving for? Sine of A. So let's do sine of A on top, okay? So sine of A over 16, okay, is equal to sine of 40 over 17, okay? And now let's just plug those guys in. I know that this is going to be sine of A equals, multiply the 16 over to the sine of 40, okay? So I'm going to go sine of 40 equals, okay? I'm going to multiply that by my 16, okay, equals, and then I'm going to divide by 17. Okay, so the sine of angle A equals 0.605. So 0.605. Now I want to solve for A. Okay, so I can take the sine and move it over to the ratio, but it's going to turn into the inverse sine. So this is angle A equals the inverse sine of my ratio, 0.605. Okay, so let's take the inverse sine of that. So inverse sine of 0.6049765,738. Okay, whatever, I copied it down. All right, so we get 37.2, let's just say 37.2. So A equals 37.2. All right, so we got that guy, it's 37.2. And now let's get angle B. So 180 minus 37.2 minus 40 equals 102.8. So this guy up here is 102.8. All right, and now all we have to do is solve for side B. All right, so we're solving for side B, so I'm going to put that here. Side B is equal to the sine of 102.8, okay, 102.8, and that's going to equal, all right, let's see, side C is 17 over sine of 40, okay, sine of 40. All right, so there we go. So to solve for B, all right, B equals, move that guy up there, so that's going to be sine of 102.8. So sine of 102.8 equals, okay, I'm going to multiply it by the 17. So times by 17 equals, then I'm going to divide it by the sine of 40. So divide by, and I'm just going to use parentheses, okay, sine of 40, parentheses, close parentheses, okay, equals, and I get 25.79. So 25 point, let's just round it to 8, 25.8, okay, and there's my side B, 25.8. Okie doke. Now, let's see. Yeah, I think you guys can do the area of a triangle. Okay, it's just in the notes. Okay, I'm not going to waste any more time here, especially with something that's just straight formula. Okay. All right. Good luck to you guys. Again, I'm in my office hours pretty much all day. If you need me, let me know if you need something. Okay. Peace.